This week, we're going to go over how to graph the tangent function. Last week was all about graphing sine and cosine, and the stuff you went over there, you had amplitude, you had vertical shift, and then you had period. And tangent has the exact same things, although we're going to go over those sort of in reverse order of how you learn sine, cosine, and tangent. So yeah, it has vertical shift and amplitude, which you'll work on Tuesday and Wednesday. But for today, what you're going to work on is number one, what is the shape of a tangent graph? How does that kind of look? And then how do we apply the period to a tangent graph? How do we decide how wide or narrow to make that tangent graph? So first to go over, we want to look at what is the shape of that tangent graph. Yeah, so in our notes here, I put a thing, again, tangent function A, B, and C, just like we would. A is your amplitude, C is your vertical shift, which again, we'll go over later. Today, we're going to focus on the B value, that multiplier on the inside, which sort of squishes or stretches things here. So how tangent works, we're going to follow this thing. Again, the word tangent means next to, right? Which we usually don't necessarily go over a lot in like geometry or things like that. Oftentimes it's just like, oh, tangent, it just means opposite over adjacent. But technically tangent comes from how far away, how far does it take to get from the center of a circle or center of the unit circle to the tangent line. That's what a tangent literally means, where like sine means, if we put that graph in here, it's just the vertical part. How tall is it? Cosine is how wide something is or how far left to right. So like here, our sine graph, which you guys did last week, tracks the height of that. And so that makes this sort of up and down wave happen. Tangent, on the other hand, looks a little bit different. Okay, so if I put the tangent in here, here's the tangent line. That's what we're going to track here. So when we hit play, you notice it looks a little different. It doesn't make the same wave as sine or cosine. I'm going to zoom out here so we can kind of see and get a look at that. Tangent makes these sort of vertical waves happening over and over and over again. And what we have here is there's sort of spots where the waves sort of cut out, where there isn't a wave. And here it repeated again, but there's spots where there are not waves there, right? There's these vertical points. These are called asymptotes. A tangent has asymptotes here where the graph sort of splits off, and then it splits off here again. There's another asymptote and another asymptote. And we can see where those asymptotes happen. I'm going to slow this down just a little bit so we can kind of see this wave going down, and it's going to form an asymptote right about here. Okay, and notice it would have to form an asymptote if this line was completely vertical, right? If the line was completely vertical, the blue line vertical anyway, it can never hit this black line, meaning there is no graph at that point. So that means for tangent, you cannot have part of the graph, right, when tangent is at 90 degrees or at the other vertical spot at 270 degrees. And you can check that. Go ahead and grab your calculator. If you try and plug in tangent of 90 or tangent of 270, your calculator will freak out and it will say, no can do, right? It'll say undefined or not in the domain. It won't work on your calculator, and this is part of why, is because when you have a vertical line, it can't intersect this thing. So we end up with these vertical parts at 90 and at 270, or as I'm going to refer to it, at negative 90 up to positive 90 degrees, right? That's how we're going to graph that, because again, 270 and negative 90 are the same thing. And other than that, it just keeps on repeating, right? And the other key thing we need from tangent, I'm going to zoom this back in a little bit, is that if we get exactly to 45 degrees, now I understand that this is not in degrees, so it's not going to be perfect at 45, because again, it's measuring stuff in radians. It's a little bit different. But at 45 degrees, tangent being opposite over adjacent, or we can just kind of check here, what's the height to this spot, or we could divide side divided by side here. This tangent value is 1, and that's important, right? Is that tangent value, no matter how fast this thing spins around, once it gets halfway through its sort of from the base back up to the top, halfway, meaning from here, right? Here's where it's sort of flat, and then to completely vertical, right? If it gets halfway to that point, the tangent has a value of 1, and that's the key piece in graphing, okay? We keep track of its period, and that goes from -90 to +90. It has a 180-degree period, a little bit different for tangent. It repeats every 180 degrees because it only takes that half turn before this line is back around again. So well, that's a little bit different thing. And then it makes this vertical wave, and we'll keep track of halfway through it's at a height of 1. Those are kind of the key pieces on there. So let's take a look at some actual examples on there. Let's actually pull this back up. Oops, didn't need to take it away. So let's see, the graph of a tangent function, okay? If there's nothing in there, right, here's how we would take that. The period of a tangent function is normally 180 degrees. It repeats every 180 degrees, but it's always halfway through. So we go from -90 to +90, right? -90 to +90. That's what's going to go here. So I'm going to put my line, or let me grab a line. So I'm going to put a line here at -90. And let's make that a little bit thicker and dotted line, and maybe we'll make it, I don't know, orange or something like that, so we can see that line. +90 up to -90. So notice it has a period of 180. There's 180 degrees from one end to the other, but it's sitting halfway in between. So 90 degrees are above, 90 degrees are also below, or to the right and to the left. And so that's kind of where we have to go from there. And then the other pieces that we need, so I'm going to try and put these in there with a little bit of circles, is that, you know, it sits right in the middle here at 0, 0. Okay, that's one spot. Let's make that, I don't know, we'll make them blue, these spots in here. So there's one of our spots, okay, at 0, 0. And then the other piece of tangent, remember when we move halfway through that circle, we get a tangent value of 1 because the opposite side and the adjacent side are exactly the same. So in this case here, what I would do is I would find, you know, about halfway in between here, right, which is about 45 degrees, I would go up to a height of 1, okay? And it's kind of trying to snap to a particular spot, but that's where I'd want it, or I can move this around a little bit. Okay, halfway through, it's at a height of 1. And then if we think about it in reverse, halfway down is at a value of -1. So here I would take this, I'm just going to copy that through. Hang on, got to zoom in a little bit here. Zoom in so we can see that. So here I'm going to take this, halfway back is at a value of -1. Okay, those are kind of the three spots. Now again, tangent doesn't make a perfectly straight line when we go through there, but those are just sort of our values to help fit it to that. That's what I'm going to be looking for when I go in and check your homework. And then to graph the rest of it, right over here, again, it makes that completely vertical space. And here it's going to come down and do this, and then it's going to go and put another, and then go vertical down here. These are these asymptotes meaning it can't hit that. And I'm going to grab the curve function again. I'm going to start really high. So I'm going to start up high, kind of come down here, right? Maybe I'll make another click in here or something. Oops, well, I'll try that again. Let's go here. All right, so we're going to start really, really high up here. It's going to come down to this point, and it's going to turn through 0, 0, turn through this one, and then turn out the other end. And it looks, you know, doesn't look anything wonderful or perfect here when I'm graphing that, but we get kind of the idea. Oh, let's make that a little thicker so we can actually see what's going on. There's the actual tangent graph, right? And that's what those ones are. And that's how we do tangent, right? With the rest of these, okay, I'm just going to show you those rather quickly in here. If we put a different value in there, tangent of 2x, that's just going to change how wide or narrow the tangent graph is. Otherwise, the rest of it's going to be very, very similar. Let's make this a little bit bigger. So if we have 2x here, the piece that we need to do, right, is I need to remember, oh, tangent is actually 180 degrees, right? So let's go here, 180 degrees, but we, just like with sine, cosine, and tangent, I have to divide by the b value, or divide by 2, which in this case is equal to 90, okay? 90 degrees. So that means the period is actually only 90 degrees in this case. So I have to be a little bit careful. So then in here, again, I'm going to just go ahead and steal the line from the last one so I don't have to remake a vertical line. So now, a lot of people will take this and say, okay, 90 degrees. Here's 90, and then I'll put my other one over here, 90, and that's where the gradient goes. But remember, the period is the full length. So here, if I put these two down, that means the period's 180, which I don't want. I want the period to be 90. So what I have to do is put this one at about negative 45, and this one at about positive 45, so that there's only 90 degrees in between these two values, right? So then I'm going to just extend that a little bit. And then the rest of it is very much the same. So I'm going to go ahead and grab one of these. Let's see if I can take one of these, steal one of these blue dots. There we go. Steal one of these and put it in here. Okay, let's zoom in on this a little bit so we can see what we're working with. All right, so I'm going to put here my blue dot at 0, right? Always going to start right in the middle, but these ones anyway. And then again, I'm going to go from my middle spot halfway to the asymptote. It's going to go up 1, halfway to the asymptote, up 1. So I'm going to grab this guy, go halfway to the asymptote, and go up 1. I'm just going to copy it right there. Same thing this way, halfway to this asymptote, down 1. Always 1, because halfway through, adjacent and opposite are equal. The opposite side and adjacent side on the triangle are equal. It's kind of like a 45, 45, 90 triangle. All right, and so there we have our base structure on there. So I'm going to zoom back out there, and then we just put our curve. So I'm going to grab my curve here and start way up high at the asymptote. It's going to drop down. I'm going to click on this dot, this one, and then all the way back down again. And, yeah, it made a little wonky, little wobbly in that middle there. That's just the computer program. That's okay. What I'm mainly looking for, when we go through, and I go through and check your stuff, do you have the asymptotes in the right spot? Do you have it make sure it goes completely vertical, vertical at the beginning and ends, right? That's step 2. And then do you have these things in there as well, right? Do you have the middle, and then halfway through you're up and halfway through you're down, right? Those few things, that's what I'm looking for. That this looks, absolutely perfect, this green line, that's, that you've connected them, that's kind of the base I'm going to check. I'm not going to go super in depth. And last example that we'll go over here, again, I'm actually going to steal a few of these parts here, right? Actually, you know what I'm going to do? I'm just going to take this whole thing, right? And I'm going to get rid of this. And I'm just going to put this whole thing in here, and I'm going to show you kind of a way you can sort of, I'm just going to manipulate this one a little bit so I don't have to do the whole thing again. So here, B value is 2/3. So in this case, what I should do is take 180 divided by 2/3, which is not equal to 90, right? Now we know that for sure. But again, when we take 180 divided by 2/3, that's the same thing as times, right, 3/2, right? We multiply by the reciprocal. So in this case, we should have 270, right, degrees in here. And so that one I have to make sure I do my math right on there. We're dividing by that number, multiply by its reciprocal, right? So now we've got to have 270. But again, 270 is the whole way. So I got to have like 135 to one side and 135 to the other side. So in here again, you could put those whole things down, right? I could go 135 this way, 135 this way, and so on. But what I'm going to do is I'm actually going to grab all of this stuff except for the background. I'm just going to grab this guy and sort of pull it out so that it's at 130. There's about 135, and I'm just going to stretch this out, right? I get it looks a little alien-y in here, but again, that's our same type of idea that we would have here. Because again, 135 all the way over, there's one asymptote, there's the other one, right? It's going off towards infinity. And maybe I don't like what this is. Maybe I'm going to pull this towards infinity a little bit more here, pull this one a little more towards that asymptote. There we go. But in there, it's the same type of thing. Halfway over, about halfway, right? About halfway in here, I should go up 1. About halfway from the middle over to the asymptote, not to 90, but to the asymptote of 135, I should go down 1, okay? That's how we get that tangent graph. So your guys' assignment is to do the same thing, right? Exact same situations, 5 questions on there. Again, if it isn't making sense, you're like, man, I'm not quite sure, send me a question there and I'll try and get back to you as soon as I can. Otherwise, good luck.